We're going to be solving radical equations. And before we do that, you see at the top of your paper, it asks you to do some warm-up exercises on lined paper. So do what that part says. The problems are coming up here. So for the first section, you're going to do some common algebra errors. Okay, so what I'd like to do is write these down and solve them. Don't write all four down at once. Write the first one down, simplify that fully. Do the second one, simplify that, third one and the fourth one. And then do that after you pause the video. Then come back and compare to what I show you here. Okay, and hopefully everything's correct. Pause and do these problems. Make sure you show all work. I'm going to have the answers up, but you need to have all the work shown for yours. Go ahead and pause now. Okay, so there in red, you see some answers. I'm going to guess if you made a mistake on this one, that maybe you squared out the x and the 3, that you have an x squared and a 9 here somewhere. This one, a super common error would be to say that the answer is x squared plus 4 or minus 4. Okay, this is wrong. X squared minus 4 is also wrong. You cannot just square the first and square the second because of the minus sign. If this is multiplication, you can square everything inside. But you have to FOIL this out. Okay, there's the correct. This one, if you got this sign wrong, you have a plus there. I'm thinking maybe you didn't distribute, or not just a plus if you have no x's. If you just had an x squared plus 0x, say, that you didn't distribute this minus sign correctly. And the same thing here, if you didn't get quite the right number or a different sign, I'm going to guess that you didn't, this minus sign, you did not distribute all that correctly. Okay, so have all the work, and if you still have problems getting these, okay, just come to class and let me know. Okay, so here once again, 4 more problems for determining the LCD. The work that you did since the last video was solving rational equations, so you needed to determine an LCD and multiply both sides. So if you can't get the LCD right, everything else after that certainly most likely wrong. So what I'd like you to do on this is just determine the LCD. So write down number 5 as written. Don't just write the answers, because you can't just study by looking at answers. You have to have that problem written down, and then determine the LCD and any work that you needed to do with counting and stuff that I showed you, and then write down the LCD. Okay, so when I'm done here, make sure you, after you write each one down, pause the video, make sure you do these all, write down the LCD, and then compare your answers to what's about to come. Okay, pause now. Okay, there you go. This one should have been fairly easy. With the 2 and the 6, it is just a 6. And then there's 1x here, 1x here, so you need 1x. Here, since the 2 denominators are completely different, they share no common factors, it's just going to be 1x and 1x plus 1. Here, and again, let's count. How many x's are here? How many factors of x? And there's 3, because it's x times x times x. There's 1 factor of x, and what's the biggest number you just said was 3, so that's why we chose the x cubed, because we need all 3. And then, you know, you can consider that this is a 1 and a 3, and you should know that this 3 comes from there. Okay, this one here, make sure, even though they look different, very different, don't write x squared minus 4 and x minus 2, okay, like we did up here because they were different. Remember, this one factors. Here, so we need the 1x plus 2, and there's one here and one here, x minus 2. So you only need one of them right there, and there you go. Okay, next you'll need your graphing calculator, and I'd like you to find the points on the line given, and this x value here is the 3.5. So there's a different way you need to get this than this, where I give you the y and you have to come up with the x. Follow along in your last notes and the work that we did from I guess just yesterday and the last lesson, and you should be able to come up with that. And also find the appropriate window. Now, for appropriate, not everyone is going to have the exact same numbers, but everyone's numbers should be very close. Okay, and just make sure that the graph, all the key features are in the window. Okay, so write all this stuff down, do the work, all the work you need to do. Now with the graphing calculator, not a whole lot of work you need to show, but just make sure you can do it. Write down all the values here, and also draw an appropriate picture on your paper that you have. Okay, just draw it here. Put in your little axes and draw it. Okay. All right, pause now. Go do that and come back. Okay, so the first thing, I took the linear equation given and I put it into slope-intercept form, which was y equals 3x plus 11 halves. And then I did my zoom standard and it drew the line. Then for the one we were given the x, that's where you hit trace, and then you can just type in the 3.5 and enter, and it looks like it gives us a 16. Okay. Alright, so this one, you see, here's my y equals window. Oh, also, hold on. Alright, I was looking here. Do you see how that's blacked out right there? If you ever see plot 1, plot 2, or plot 3 highlighted, you need to unhighlight that. That would be bad. So let me show you. So see how I have this blinking up here? I'm going to enter on that. Okay, and you see how that is highlighted? That's why I was looking at this. I don't know why that's black. So if you ever see this highlighted, get that off of there. That's used for some different things than where we're doing right now. So just arrow right onto that, enter on it, and move off, and make sure that is not highlighted. Okay, so once I have that, here's my graph down here. So I put in the line y equals 2.35, and we're going to go ahead and look for that intersection right there. So we're going to use calc, and we're going to find the intersection, which is number 5. Okay, first curve, yes. Second curve, it's on the other one, yes. And then guess, and I'm going to go ahead and arrow over right to that intersection, real close to that. And you see that the y value is 2.35. That's right, exactly what we have. And it looks like we have x is negative 1.05. All right, so let's come back down here. And let's see what we got. All right, so here we had a 16. Over here we just got negative 1.05. All right, and then whatever our window was, here, just come back and fill that in. So next I put in the absolute value of x cubed minus 15. And at first I'm going to go ahead and zoom standard. Okay, and then just a quick inspection of the table. So as you get very negative up in here, so as you go -8, -9, -10, you see this number getting huge, which agrees with this. As you go further this way, this is just going to continue to go up. So we know it's not going to come back down. And then we see this number getting lower and lower down here. And it looks like we get down to around a -15. And then it's going back up. It's increasing, it's increasing. So as you're increasing, and it's increasing, and it just keeps going without bounds. So it's not going to come back down. So then from there, let's choose an appropriate window. All right, so we need to change this y minimum. And let's just go with the y minimum, say -20. And when we arrow off of that, you see that we get that on there. Okay, that one's pretty good. We could narrow this up a little bit. So let's squeeze that in. Let's say our x min could say be -5. And max could be 5. Okay, and then if we increase this y value a little bit, I think we'll get a good picture. Even 100. See what happens. You can go with a 50. See what happens. Just play with it a little bit. So see that rounded that off a little bit there. So it gives us a pretty good picture. We get all the key features on there. We know it goes up and out forever, up and out, and we know it's kind of rounded off. When I had that as 100, it looked kind of flat right there. So at least that kind of rounds that off a little bit. So I think this is a pretty good window. All right, the only thing I can say here is if we look at this, although we see all our key features, if you notice the x-axis has some tick marks going out, right? So the x-min goes from -5 to 5. You see that. Well, look at the y-axis. We're going from a -20, right, to a 50. If you take a look, you can't see tick marks here, but it looks like the y-axis is really thick. And I think that's caused by this the y scale, in that there's a tick mark every 1 unit, which means from the x-axis up, there's going to be 100 tick marks. Now, maybe you can see them. My eyes aren't so good, but if there's 100 tick marks in there, to me it looks like a solid line. So I think we should change that. So let's just play with that a little bit, see if a 5 fixes it. I'm not sure we're actually going to see them. I'm not going to leave it a 5, but let's see what happens, just so you can see what happens too. So I change it to a 5. Oh yeah, there's lots of tick marks there. Okay, because if you count up, let's see, our Y max. Okay, our Y max is 50, so there basically should be 10. 1, 2, 3, 4, 7, 8, 9, 10. So there you go. But the tick marks here are, a lot narrower than these. So how do we get these a little, further apart so there are less tick marks? Just increase our Y scale. Since we're going up to 50, if we make this 10, then there should only be 5 down here, right? So let me scroll off of that. There you go. So now we're counting up by tens. 10, 20, 30, 40, 50, and -10, -20 in the other direction. Okay, so by changing that, we now have, a fairly good graph, and you can see the tick marks. You just have to remember that these are still counting out by ones, and these are counting out by tens.